Hello and welcome to the next video in my series on television technology. In this video, I'm going to have an in-depth look at what's contained in the digital bit stream that gets transmitted from the TV station. Now, in order to do that, I'm going to be doing everything on a Linux host. I'm going to control it from the Windows box here, but everything's done on a Linux host in another room. Now, in the previous video, I showed how to install the DVB adapter in Linux, and I'm going to be drawing on that for most of this video. So if you want to learn how to get set up in order to do this, just watch the previous video. Now, all the examples I'm going to do, I'm just going to base on ABC. So let's rip into it now. Now, in the previous video, we made a channels.conf file, which contained all the TV stations that are transmitted on all the frequencies. Now, as I said, I'm only going to concentrate on ABC for this video. So I just want to focus on these first few here. So what I'll do is I'll just narrow this down a bit. Rep just for things in that frequency, channels abc.conf. Okay, so now it's just a bit smaller there. Okay, so what does it mean? First of all, we have the TV station name, obviously, the frequency it came in on, inversion, the bandwidth, in this case 7 meg, the forward error correction for these two, the constellation, which in this case is 64 QAM 64, transmission mode is 8K, the guard interval is a 16th, there's no hierarchy, and these three values here are the PIDs that we're going to look closely at. This one here at the end represents the PID for this ABC News, okay? These two, the first one is the video PID and the second one is the audio PID, okay? So if we go along, we see ABC has 577, ABC Comedy has 578, ABC Me 580, and we go to 8, we've got another ABC, so we've got two just ABC ones here. Even though they've got different PIDs for their actual program designator, the video PIDs are the same. The audio PIDs are the same. So it's the same channel, it's just there twice. And then we've got ABC HD, and the last two are radio stations, Double J and ABC Jazz. That's why their video PID is 0, okay, because it's just audio, obviously. Now, when I say PID, that's a packet identifier within an MPEG transport stream. So what I'll do now is I'll tune in ABC's frequency and we'll have a closer look at the PIDs that are contained within it. Okay, so to tune in one of the channels using the adapter, we make a directory called .tzap, and we copy the channels config file that we created to that directory. Now, we just run the tzap command with one of these station names. It doesn't matter which one, it just tunes the frequency. So I'll just do tzap ABC. And what that does is tune the adapter in. Now I'll just go through this briefly. Signal, self-explanatory. That's the signal coming in. Now those numbers are kind of arbitrary. A bigger one is better, but they can be different from adapter to adapter. You've got your signal to noise, which you'd hope is pretty stable, which this is. Bit error rate, which ideally is 0, but low is also good because we can overcome some errors. Uncorrected blocks, that's also 0, or pretty low. And this is the important one as well. Front end has lock, so that's the front end of the receiver. So it's locked, we've got good signal to noise ratio, very low errors, so the signal looks pretty good. Now that program tzap simply tunes the adapter in so we can use it. But I'm going to install another program called DVB-Snoop, which lets us have a closer look at what's going on. So I'll do that now, and it's only a small program. DVB-Snoop. Okay, it's in there now. So I'll just maximize this. We don't really need to see what's at the bottom. It's still running though. So now that that's installed, we can go DVB-Snoop and do a scan and do a PID scan. Now this takes a little while to run, but you can save it to an output and just reference it from future if you want. So I'll let it run first so you can see what's involved. And here it comes. So all these PIDs, these packet identifiers I spoke about, this DVB-Snoop tells you what they're all about. So I'll just let that finish. Okay, that's done now, and I've got a list of all the PIDs that are in that transport stream. And as I said, I've just also put the output in a file just so I can reference it easy without having to wait for a new scan every time I want to refer to it. Now we've done a PID scan, we can have a closer look at what's inside it. So I'll start with PID 0, which you can see is this program association table. Now we'll just do a DVB-Snoop on that, and there we get lots of stuff. Now that's constantly coming in, right? So I'll just stop that. Now if you have a look at these numbers here, 576, 577, 578, they are the same as up here, 576, 577, 578 from the channels comp file that we made. Now if I look at the first one, just use that as an example, 576 is ABC News. So if I go back here and see 576 for that program, we see there's a program map with this PID, which in hex is that. So we go DVB snoop on that one for program number 576, and we see all this stuff. And again, that's just constantly coming in. So I'll just stop that and scroll up to the start of it and have a bit of a look around. So what do we see? Well, we can see some PIDs within that, and we'll start with the one that says video. Okay, so that says that contains video there. Next one says that's audio. So it's mapping these different video and audio streams together to make the program stream for ABC News. The next one, what's this one? It's teletext. Okay, that also comes in. So all of those are grouped together with that overall PID that is the TV channel. Now another thing you can do with DVB Snoop is look at the bandwidth of individual PIDs. Now what I'm going to do is look at the video PID for ABC News, which is this one here. But this is in decimal in the channels comp file. So the hex version of that is 90A. So just DVB Snoop S, which is the scan type, bandwidth, and the PID. So if I run that, there you can see the bandwidth live of what's coming in for that video PID for ABC News. Now that's good and well, but there is another program called DVB Traffic, which is much better at this, I think. So if I run that, it presents it nicely. So I'll just pause that, and you can see 90A, which is here. You can see the same thing. You see the bandwidth here, but you can see all of them in real time. And the interesting one is down the bottom, 2000, which is actually a dummy PID, but it represents the whole bit stream. And it shows me that we've basically got 23 megabits a second of digital data coming in. Now, if you remember back when I showed the RF side of this, there's 7 megahertz of RF bandwidth, and this shows that in that 7 megahertz of RF bandwidth, we can get 23 megabits per second of digital bandwidth. Now, what I've just shown you there is MPEG transport stream. And what you've probably mostly dealt with on computers is MPEG program stream. And the big difference is with a normal MPEG file or something, you can just ask for the file and you get it from a network or a drive or something. But with transport stream, it's designed for things like TV, where it's just transmitted and you can't ask for, if you've missed a few packets, you can't get a retransmission because it's over. You're just getting sent stuff all the time. So with MPEG transport stream, you can have, they do have, extra bits in there for error correction, which is what you might have saw when I showed you that channels comp file, some of the error correction parameters. That's just so it can recover if there's a few errors. Now obviously if there's too many errors, you'll get errors on the screen, but it can recover from a few errors due to those extra bits that get transmitted. Now another thing they do at the TV stations is, instead of just saying, okay, this channel can have this much bandwidth, that one can have that much bandwidth, they know that they've got 23 meg overall, or whatever they've got. So they use a statistical multiplexer to encode the right bit rate for the type of video that's on each program. So for instance, if you have a sports program, there's usually lots of movement, so the picture on the screen is constantly changing, so it's generally higher bandwidth required for that, as opposed to, say, a newsreader who's just sitting there, like say I am now, where there's not much of the scene changing, so it would be a lower bit rate requirement. So what a statistical multiplexer will do, it'll take it frame by frame and say, okay, we need extra bits for this because that's got a moving scene and that's not so much, and then it sends the whole transport stream out of the transmitter. And that's what ends up here. We demultiplex it, get the program streams, and we watch TV. So that's what the TV stations put in their digital bit stream that they transmit. Now in the next video, I'll show you how we can get that and use it to create an IP multicast group to create IPTV over a computer network. So check that out.